Well, hello. In this video, we're going to be looking at how we can use logarithms to actually solve an equation. Because in the past, we've seen equations like the one above me, and we've had to solve it, like if we wanted to figure out how long it would take for that investment to grow to be $5,000. Before this lesson, the way we would solve this is we would set up a system of equations, and we'd graph them on our calculator and find where those two equations would intersect, which works. However, you need to make sure you know how to change your window settings and know what to change your window settings to so you can see where the intersection is, and it can be kind of a tedious process. And plus, you need to have a graphing calculator for you to be able to do that. Well, in this lesson, you're going to get to see just how powerful logarithms can be because we can use those to solve exponential equations. Now, in order for us to be able to do that, there's a couple of different options. One option is going to be to follow a 5-step process. That is relatively simple, just involves a little bit of algebra. And there's another method I'm going to show you that involves only 3 steps. It just requires you to know more how to convert from exponential form to logarithm form, which you should already know how to do. But you'll have the option of using either technique, and I'll show you both of them as we go through a lot of our different problems in this lesson. So let's go ahead and start by looking at what that 5-step process looks like. So here you can see what those 5 steps are. The first step is to isolate the exponential term. And what I'm going to do is we're going to go through these steps as we look at this example down below. So if you look at the example down below, the exponential term is 1.06 to the t power. So my first step to isolate the exponential in this case would be to divide both sides by 1,250. When I do that, we get 4 equals 1.06t. So now I'm on to the second step. The second step is to take the log of both sides, and we can use any base. And if we have that option of using any base, it makes the most sense or the easiest to use a common log or a base 10. So if you look at that example, they took the log of both sides. Now we would have the log of 4 equals the log of 1.06t. Now the third step is to use the log properties to bring down the exponent. Because remember those properties that we talked about a couple of videos ago, if we have an exponent and being applied to the value, we can plop that exponent and park it in front of the logarithm. And so that's what they did here in step 3. So you can see now that we would have on the right side t times the log of 1.06. And our fourth step would be to solve the variable. So if we solve for the variable, I would want to divide both sides by the log of 1.06. And now I have t by itself. And the last step would just be to plug that in on your calculator or evaluate it on your calculator. And if you evaluate this problem on your calculator, take the log of 4 divided by the log of 1.06. It doesn't matter if you have a scientific calculator or a graphing calculator. You'll be able to plug that in and get your answer of approximately 23.7913. Or we could even say 23.8. So that process works. Now there is another process that I want to show you that can do this in a lot less steps, but again it requires us to know and remember how to convert from exponential form to logarithm form. So this one again only has 3 steps, and it also, the last step gets a little bit trickier if you don't have a graphing calculator. So when we get to that step, I'll show you what I mean by that. So the first step, just like the previous one, is to isolate the exponential term. So the first step is the same. If I divide both sides by 1,250, I get 5,000 divided by 1,250 gives me 4. So the first step in this process is no different from the previous one. But now this is where it gets a little bit different, because now we're going to convert this to logarithm form. And so remember, with our logarithm, we have our base, and our base in this problem for our exponent is 1.06, and the value is 4. So if I convert this to logarithm form, I'd have log of, with a base of 1.06, with our value of 4 equals our exponent, which is t. And now the last step, we're just going to plug this in on our calculator. Now, if you have the TI Inspire and you hit the log button, remember you get to type in any base you want. But if you're working with a scientific calculator, we have to do one extra step. We have to use what's called the change of base theorem. Don't worry so much about the name, just make sure you understand the process. Where if you have the log with the base b and a value a, you start by taking the log of whatever your value is, the log of a divided by the log of b. So in this problem, it would look like the log of 4 divided by the log of 1.06. And again, you only have to do that step that I have here in purple if you have a scientific calculator. If you have a TI Inspire graphing calculator, you just plug this in and get your answer of 23.8. So you get the same process, get the same answer, just in a shorter process. And you will have the opportunity to choose whichever process you would rather do. So I would encourage you to try both of them so you can see for yourself which one you like best. Let's look at some examples. So here it says you borrow $100 at 15% interest compounded annually. How many years does it take if you don't pay it back for you to owe $1,000? So this is one of those compound interest problems. It's compounding annually though. So we would take and set up our initial amount, or our principal would be $100. We could take and add 15 because it's 15% compounded annually, so that would be 1 plus 0.15 or 1.15, and our exponent is going to be our time because we're trying to figure out how many years it would take to pay back, or how long it would take for us to owe $1,000. So here we have an exponential equation. So for this problem, your first step is to get the exponent or exponential piece by itself, so we divide both sides by 100. It doesn't matter which process we're going to use, that first step is the same. Now I'm going to show you the second process, the shorter steps first. So for this problem, the next step would be to put this in logarithm form. So our base would be 1.15 and our value would be 10, and it's equal to our exponent, which is t. We plug that into our calculator and you get your answer, 16.5 years. Now, like I said, there's another method we could use using the log of both sides. So if I put down the log of both sides, the next step is that t, that's my exponent for the 1.15, we just plug that or park that in front of the logarithm, and then to get the t by itself, we divide both sides by the log of 1.15. Now, if you notice, this is taking basically our change of base theorem, because if we went back to what I had in purple, and if we didn't have a graphing calculator, remember we'd have to use that, what we call the change of base theorem, and type in log of 10 divided by the log of 1.15. So this is another way to get to that point. Either way, you get the same answer. Let's look at the next one. You invest $400 at 5.4% compounded continuously. How many years does it take for you to have $800? Well, we see that phrase compound continuously, so that implies that we're going to use PERT. So this one's going to be slightly different. So we'd have our $400 as our principal times E, our 5.4% as a decimal is 0.054 times T equals the amount that we'd have, which would be $800. So the first step, we divide by 400, giving us a nice little number of 2 on the right. Now for this problem, if we're going to put this in logarithm form, remember what we learned about most recently is the log of base E is the natural log. So we'd have log base E, or natural log of 2, equals our exponent. Divide both sides by 0.054, and we get our answer of 12.8, so it'd be 12.8 years. Now for this problem, if we were going to take the log of both sides, since we're working with a base E, we'd want to, instead of taking the log of both sides, we're going to take the natural log of both sides. And now we would plug, or park that 0.054t in front of the natural log, giving us this. Now if you remember, the natural log of E would just be 1, because if you have a log base E of E, our answer would be 1. So that really does not affect anything. So I'm just going to divide both sides by 0.054, and if you notice, if you compare what I have here in green to what I had in purple, it's the same exact thing, giving us the same exact answer, 12.8 years. Okay, I want you guys to try these next 2 problems. Some of these problems are going to require you to remember what we did in the previous chapters, setting up an exponential equation, so hopefully remember how to do that. But otherwise, why don't you try these next 2, 3, and 4 on your own, and hit play when you're ready to check your answer. Okay, so let's see how you did. For this first problem, or for number 3, we would set this one up to be 37.6 is our initial amount of people there. And the 3.3%, remember from the previous chapter, you'd have 100% of your original population. You're adding, you're growing it by 3.3%, so you'd have 103.3%. As a decimal, it would be 1.033. So that would be your growth factor. and then we'd have our time is what we're trying to figure out, so that's our x. We're trying to figure out how many years it would take for the population to reach 50 million people. So then you should have divided both sides by 37.6, and then it doesn't matter which method you use, but again, I'll show you the shorter method first. We would take and put this in log form, so it would be the log with a base of 1.033 with a value of 1.33. Plug that in your calculator, you get 8.8 years. Or you could take the log of both sides, and then you would put the x in front, divide by the log of 1.033, and get the same answer. Let's look at number 4. You buy a car for $25,000. It depreciates at 5.5% a year. How many years does it take for it to be worth $12,500? Now this one's kind of tricky, because your initial amount, your principal, would be $25,000. It's depreciating. We're losing value. We're losing 5.5% a year. So if I subtract that from 100%, we're going to get 94.5%, which as a decimal is 0.945. So that's what we use as our growth factor there. And we're trying to figure out how many years it would take to be worth $12,500. So now we would start this one off the same way as the other ones. And if we wanted to, we could put this in log form and type that in your calculator and get 12.3 years. Or we could put the log in front of both sides, put the x in front of that first logarithm, divide both sides by the log of 0.945, and get our answer of 12.3 years. Okay, so for the rest of these problems, I can't take, if you look at all this work that we did in these previous 4 problems to show the 2 different methods, I can't do that for all of these. Personally, my preference is what I did there in purple, doing it in less steps, getting the same answer. So just know that for the rest of these examples, I'm going to show you just this shorter process. If you prefer using the other method, you are more than welcome to, and this process will still work for all of these next examples that we're going to look at. Because all we're doing here is we're just solving equations, so these are not story problems, these are just equations set up for us, but it's still going to be the same process. So remember, for all of these, we're going to first start by getting the exponential part by itself. So next I would want to subtract 7 from both sides. Doing so gives me 11 to the n plus 1 equals 43. And this would be the point where if you wanted to take the log of both sides, you could, but again, I'm just going to use the shorter process. So I'm going to put this in logarithm form. So my base would be 11, my value would be 43, and it's going to equal n plus 1. And if I type in log base 11 of 43, I get approximately 1.6. So now to solve for n, we just subtract 1 from both sides, and we get 0.6 as our answer. So let's look at number 6 together. In number 6, we want to get that exponential portion by itself, so I divide both sides by -7. Doing so gives me 3 to the 2x power equals 5. Now I can put it in logarithm form with my base 3 and my value of 5 equals my exponent of 2x. Log base 3 of 5 is approximately 1.465. Divide both sides by 2, and I get my final answer of x equaling 0.73. So why don't you guys go ahead and try the next 2 examples on your own. So pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, so let's see how you did. So for this one, we want to get the exponential, the 7 to the 2n power by itself. So for this one, we actually want to do 2 pieces. You want to start by subtracting 1 from both sides, and then divide by 4. And now you'd put it in exponential or logarithm form. So you'd have log base 7 of 3.5 equals 2n, which would be 0.644 equals 2n. Divide by 2, and we get 0.32. Let's look at the other one, number 8. You should have gotten the 18, that portion by itself, by subtracting 10 on both sides. You could put this in logarithm form and get log base 18 of 45 equals 2x plus 3, or 1.317 equals 2x plus 3. Subtract 3 from both sides, divide by 2, and you get your final answer. Well, there you have it. That is how we solve an exponential equation using logarithms. Remember, you have the choice of using either method, but you just want to make sure you show your work and make sure whichever method you choose that you're feeling really confident about it. Both methods have the pros and cons, but I think you'll find that once you've practiced these, that they're really not that difficult. So good luck now as you work on your assignment.